Minglava. In these videos, we are going to introduce about data preprocessing for machine learning modeling. Before we do that, let's look at the machine learning modeling workflow, which we have covered in data science projects. So before we do the modeling, we need to preprocess the data to make sure that the data is ready for modeling, suitable for the models. Next, we split the data into training dataset and training dataset, testing dataset, and verifying datasets before we do the modeling. Model evaluation is to make sure that the accuracy of model meet the requirements of the from the business perspective, and then we fine-tune the hyperparameters to improve the accuracy. So in this course, we are going to learn more about the data preprocessing. Data preprocessing is required test for cleaning and making the data suitable for our machine learning models. This includes data wrangling, exploratory data analysis, feature engineering, data standardization, and encoding the numerical data into numbers and many more others. Right? So in our previous course, we have covered more of the data cleaning and exploratory data analysis. So in this course, we are going to focus more on preparing the data for the machine learning model. Right? So this step comes after the data cleaning and EDA, exploratory data analysis. So if you need to refresh on the EDA, please watch other video in the data science introductory course in these channels. Right? So now let's briefly talk about the creating new features. Creating new features, sometimes it is also called the feature engineering. All right. So we may want to create the new features based on the available numerical feature. For instance, computing the statistical values, or like calculating the sale amount from the price and quantity variables. So this is how you are going to create a new numerical features, right? Or it could be possible that you are creating a new features by extracting the information from the date, right? For given examples, we can see that month and year information are extracted from the given offense date features. Okay. Next, we may also extract the number or subset of tests from a given variable, string variables. All right. So, for example, vehicle number is given in this data set. Okay. We know that the first two alphabets refer to whether these vehicles belongs to the private, public, or government. All right. So, for that, we may want to extract the first two alphabet from this given string and create a new variables, which is a omit. Right? So, but creating features really depends on the data set that you are working on. Sometimes we might not need to create new features if the given variables are sufficient enough for you to do the modeling. All right. So now in this part, we are going to talk about the two data preprocessing process, which are essential prerequisites for the modeling. Right? So let's start with the data standardization, which is for the continuous numerical values. This step is critical for the machine learning method, especially for the linear models where you use the linearity measurements. Right? So now let's look at the data set given. Right? This data set gives the performance of students in the quiz 1 and quiz 2. And our goal for the machine learning model is to predict the scores that the students will get in final quiz. Right? So if we use this data set as it is for the machine learning modeling, the score from the quiz 2 will have the stronger influence. Because the quiz 2 score was based on the 100 marks, and then quiz 1 result is out of 20. All right. So these quiz 1 and quiz 2, the features have the different scales. One is from 50 to 20, the other one is from 60 to 100. So definitely when you calculate the total quiz based on the linear models, Quiz 2 will have the strong inference, and then your model will not be able to predict accurately. So for this reason, we want to make sure that our features are on a similar scales, right? So to achieve this, we have to normalize our data. This is a process we call data standardization. Two common methods used for data standardization are standard scalar approach and minimum maximum scaling, right? In the standard scalar approach, the feature is the variable is scales to have the Gaussian distribution, which is the mean values of 0 and unit variance. Right? The formula given is x nu equal to xo minus x nu by standard deviation. In other words, the average value of from the average values is subtracted from the your original data set. This gives you the average value of 0 and divided by the variance. Right? Next common method used for this standardization is minimum maximum scaling. Right? So in minimum maximum scaling method, the variable is scaled so that the range of the variables fall into the given range. Right? Most of the time it is between 0 and 1. So the formula is given like x nu equal to x original minus x minimum divided by x maximum minus x minimum. These are two common methods for data standardization. Of course, there are many more methods for the data standardization, which is out of this course. Right? Now, let's move on to the categorical data. So this approach for data standardization is numerical for the numerical values. And we know that for machine learning methods, right, especially under the skland, okay, it is necessary. The machine learning methods are work only on the numericals and numbers, right? So we need to encode the categorical values into the numbers. Okay, so let's look at the given data set here for the traffic accident, all right, traffic offense data set. Okay, so in this data set, we can see that vehicle type name and genders are categorical values. Okay, in the vehicle type name, there are three categories: heavy vehicle, medium vehicle, and light vehicle. Okay, and under gender, we have male and female, right? So we have to encode these categorical data into our new numbers. One is we can use the factorization where heavy vehicle is replaced with 0, medium vehicle is replaced with 1, and light vehicle is 2. This kind of approach is good, but this can generate the error in your machine learning models because for this vehicle type name, the categorical values are just a nominal. They are not ordinal. But by giving the 1, 2, 3 into these different vehicle types, it became an ordinal in your continuous values. So this can create a error in your machine learning models. Right? So for this, to avoid all this, one of the common method we usually use is called one-hot encoding. Okay, so one-hot encoding method creates the dummy variables. Okay, dummy variables. All right. So here, for example, we have three vehicle type. It will create the three dummy variables. Then each of them will have like values of 0 and 1. Right. For example, like for the vehicle type name, you will have the three new dummy variables. One is like is heavy vehicle, is medium vehicle, and is light vehicle. For its heavy vehicle variable, you will have the value only 0 and 1. One for the record that is for under the heavy vehicle categories. The remaining will be 0. Likewise for medium vehicle and light vehicle. The problem with this one-hot encoding is that when you have the multiple categories and now one variables, your dimension will be exploded. All right. So we may need to use the dimensional reduction method such as PCA to reduce the dimension of your train data sets. All right. So we will cover more about the dimensional reduction in the next videos. Okay. Congratulations. Now your data is ready for the modeling. Right? So in the next video, we will learn how to use one of the most popular Python library, which is scikit-learn, to develop the regression models. Then we will move on to the classification and clustering. Thank you. See you all in the next video.